Today I'm going to talk about indoor air quality and 7 steps to improve indoor air quality. I recently listened to a podcast, and Allison Bales was discussing the 7 steps to good indoor air quality, and I thought about how I had done all of these and wanted to relate that speech or discussion to what I've done on this house. So the first one is source control. Source control is important to remove all of the bad stuff at its source before it has time to disperse throughout the house. So one of the first places is a range hood. And I've done some videos about this particular range hood in the past. But what this is going to do is, as you can see the smoke here, this is obviously going to take away all of the bad stuff from cooking. Now we don't have a gas stove, so there's not going to be any CO here, but there's still a lot of chemicals that come off when things are heated up. It's good to remove those, as well as excess moisture. Another place for source control would be bathrooms. So in this half bath, we're mostly just worried about the toilet. So if there's odors coming out of the toilet, all of those are going to be taken up and sucked into the ERV system. So those will be taken outside, and then fresh air will come in. In this bathroom, we're worried about toilet, but we're also worried about humidity, excess humidity from the shower. So this ERV vent will take away all of the excess humidity out of this room and vent it outside, and then it'll be replaced by fresh air. This bathroom here is going to generate humidity as well, and the toilet. We have a big ERV vent here, and that's going to suck away. Another approach for source control is, let's say you had some trash in the trash cabinet, and it had some odors to it. If you look at the smoke in here, this is all going to be pulled inside, because there's an ERV vent inside of this cabinet that depressurizes the cabinet so that any odors that are inside of it will be pulled outside. Another source control would be the radon system. So by depressurizing the subslab and removing those gases, we are addressing the radon at its source rather than letting it mix in with the rest of the air in the house. Step number 2 is air tightness, and I was able to achieve a 0.23 ACH50 on this house, which is very, very good. The way that I was able to do that was through the construction methods and the materials used. So here we have tilt-turn windows with triple seals. The triple seals are obviously superior to like a double hung window. Those kind of lock right in and seal everything together. And the way the air barrier was continuous throughout the whole house added to its air tightness. So the purpose of having an airtight house is to gain control over the environment. Once we have control over it, we can regulate what comes in and out of the house. Number 3 on the 7 steps is filtration. And you can see here, we've got a 24-inch by 24-inch by 4-inch thick MERV 13 filter on the air handlers. 2 air handlers in the house, and they both run 24/7. So it's always moving a small amount of air throughout the house. Here's the second air handler and filter. And this is doing the majority of the work by moving air slowly throughout the house all the time. So it's always pulling air in and out of this MERV 13 filter, and it's always scrubbing the air. There's an extremely low pressure drop. I think it's 0.006 inches of water column across this. It's way oversized, and the purpose of that is to reduce that static pressure and allow air to move freely while still having that MERV 13 filter to capture all of the contaminants. That's going to get rid of some of the PM 2.5 as well as larger particles, pollen, and dust. Another aspect of filtration is this pre-filter. This pre-filter is going to catch a lot of like dog hair and large particles from getting into that larger MERV 13 filter. Now in the ERV, I do have a pre-filter that comes in the intake air comes in this way, goes through the pre-filter, and then goes into the ERV here. The ERV then has some MERV 8 filters, but this is also going to filter the air as it comes into the house. The dehumidifier also has a 2-inch MERV 13 filter on it. So as that's circulating air when it needs to, it's going to filter that air as well. Number 4 is ventilation. So the ERV is going to take care of our ventilation. It's going to bring fresh air in through that filter, like I said, and it's going to take that air into the living space, and it's going to bring stale air from the bathrooms and take that out of the house. So the constant ventilation, this thing runs at a low speed all the time. It's always going to bring air into the house and exhaust stale air out. And then it has a boost mode, so if you take a shower or there's some contaminants, maybe you're spraying some hairspray or something, you can hit the boost and remove extra air out of the house. Number 5 is dehumidification. So we have a Santefe Ultra 98 ducted dehumidifier. So this is going to take some air from the basement, but it's also got a central intake up in the stairway area, and then it dumps all of the dehumidified air into a mixing hallway. And that mixing hallway then gets pulled directly back into and across this large MERV 13 filter, gets conditioned, either heating or cooling, and then moves up into the house. Dehumidification is important for indoor air quality. It's going to reduce the amount of mold, mildew, bacteria, viruses, as well as the health of the building. So it's not going to be too much moisture in the building and create a scenario where there might be accumulation in the walls or rotting. So the dehumidifier is important. It's number 5 on the list of steps for indoor air quality. Number 6 on the 7 steps to good indoor air quality is pressure balancing. So we want the interior of the house to be equal to the exterior pressure of the house. Here I have a probe set up into the garage, and the garage pressure with reference to the interior of the house is about 0. This is moving around a little bit because of the wind outside. It'll bounce plus or minus 1 Pascal back and forth just due to the wind. But the house pressure is equal to the exterior, and I did that by balancing the ERV, so that way we didn't have, like I said, pressure balances inside and out. Now the reason why this is important is because, like I said, this is a garage out here, and if there were fumes or stored gasoline, any chemicals out there, and you had a depressurized house, those fumes could leak in through the doorway, and then you'd have all of the CO or VOCs or chemicals leaking into the house. And obviously that isn't going to be good for indoor air quality. All right, another aspect to pressure balancing is balancing pressures within the house itself. So we have a central return here, and there's a bedroom behind that. So there's a supply in that bedroom that comes, the airflow is going to come back into this hallway. The way it does that is by underneath the door, but we don't want a large amount of pressure buildup. So here you can see the airflow is going to come back into this central hallway from the bedroom. We don't want a large pressure buildup, and here you can see that it's only 0.4 pascals. So there's a tiny, tiny little positive pressure in that bedroom that pushes air out, but it's not large enough to create any issues where the air inside that bedroom will be trying to be pushing out to the outside, or depressurized to the point where air would be trying to be sucked from the outside into the room. All right, so another aspect of this pressure balancing, you can see this hallway here has a lowered ceiling, and it has that entryway into the bedroom. So I refer to this as the mixing hallway, and the reason why is because there's a bunch of vents in here. So this one here is the central intake. So you can see all of the smoke is going inside of there. So this is pulling a couple hundred CFM all the time, 24/7. and then going through that large filter we talked about. So with these 3 vents here, this one here is the ERV supply. So this is bringing all outdoor air into the house. It all comes into this one central location and then gets pushed over and sucked into the main ducted heat pump. So that's then gonna refilter and then condition the air, either heat or cool. The reason why I call this a mixing hallway is because we have colder air. The air temperature is 54 degrees, roughly 54 degrees, 36% humidity, whereas the interior air right now is 66 degrees. So that cool, dry air, because it's February in the winter, that cool, dry air, rather than duct pushing that into bedrooms, I put it in this mixing hallway, so that way, like I said, it goes into there and then gets conditioned for temperature, as well as humidity. These 2 here are for the dehumidifier. So all of the dehumidified air comes into this mixing hallway, and then again, the same thing goes into the central ducted heat pump where it gets reconditioned for either heating or cooling. That way you don't have a mass of air, dry air in any particular place in the house. This central ducted heat pump will then redistribute all of this dehumidified air and or outside air for temperature, and then recirculate it throughout the house, as well as refilter it through that massive MERV 13 filter. Another pressure balancing step in this house was a makeup air damper. So this is a pressure balancing switch. When that comes on, it senses the pressure differential and opens the damper in the basement. This is the damper that gets electronically opened. You can see the damper is open now and the airflow comes in. This is how it equals the pressure when the exhaust fan on the range hood opens up. Number 7 on the list is indoor air quality monitoring. You're never going to know if you have good indoor air quality unless you actually monitor it. There's a ton of monitors on the market, and there's a lot of different things you can monitor for. So this one here is a CO2 monitor, the RNet 4. These are relatively inexpensive. I think they're around $200, $250 each. They work great for monitoring CO2 temperature and humidity. CO2 isn't necessarily unhealthy on its own unless it's in really, really high concentrations, but it's a good stand-in for determining what your air exchange rate is. So how much fresh air you're bringing in from the outside as opposed to stale air inside. So keeping this CO2 levels under 1,000 parts per million is a good stand-in for indoor air quality, because that way you're going to know that you're exchanging inside air with outside air at a reasonable rate. If you overventilate, this is going to be a very low number like it is now. It's 595. There's nobody living in this house, so 595 is a pretty low number. Outside is 425-ish. Generally, it's going to be between 600 and 1,000 parts per million. Other things you could monitor would be VOCs and particulates. So like PM 2.5, PM 10 would be good things to monitor to make sure you don't have a lot of that, those particles building up that could affect your health. All right, so these 7 steps are described as like a layered approach to good indoor air quality. If you only do one of these things, it's not necessarily going to equate to good indoor air. Doing all of these things will add to the likelihood that you will have good indoor air quality. But again, you got to monitor it and make sure you're not doing silly things. One other thing I want to mention is that all of these systems are all separately ducted. So the cold air return, filter, heat pump, all of the heating and cooling system is not directly connected to either the ERV or the dehumidifier. These are all separately ducted, and then they go into that mixing hallway. That mixing hallway disconnects any of the pressure imbalances that may be caused if I were to take that ERV and just plug it into the ductwork of the heat pump. Same thing with the dehumidifier. If I were to take that supply and just dump it straight into this. The intermittency of that supply air is going to change the airflow rate, or the return airflow rate for the heat pump system. So if you're building a house, these are 7 things you can do, 7 strategies you can take in order to improve indoor air quality. And it's something that really all new homes should be doing.